Hello and welcome to another video from Flash Jazz Cat, and I can hear you already. What on earth is this? Well, it's an Amiga 600. I do fix machines other than Ataris, and if you come here expecting nothing but Atari, I do apologise, but I thought this would be interesting to feature. It's something a little bit out of the ordinary. It does get a little bit monotonous from time to time when you're just fixing the same kind of machines with the same kinds of issues. A gentleman from Gateshead brought this and an Atari ST, an ST-FM in. Neither of them boot up. Now, I did have one of these machines a long time ago, back in the late 90s I think. Unfortunately I gave it away. I was given it free of charge from a friend, and eventually I gave it away. I did like it, but I didn't have a decent monitor at the time. I was using it with a TV. So unfortunately I don't have one anymore. But yes, this is an Amiga 600, so as you'll know, this is the kind of the second generation consumer Amiga. You also had the somewhat more powerful Amiga 1200. I have got a couple of Amiga 500s from, I guess that would be the very early 90s when they were manufactured. Certainly the ones I've got. One of them's got an upgrade, it's got an IDE hard disk. This one, as you can see, it's missing a couple of keycaps. That's probably easily rectified. What it really needs is a retrobright, of course, but that's not the primary problem. The primary problem is that it doesn't work. I have had it apart, I have taken the screws out just for full disclosure. But let's have a look anyway and see what happens when I turn it on. But first, a word from our sponsor. Oh, hello there. This video is sponsored by PCBWay, who offer a wide range of PCB prototyping and manufacturing services. PCBWay also offers CNC machining service, sheet metal cutting, 3D printing, and they'll even print you a flexible PCB. So if you're in need of a prototype PCB, or you've got any electronics manufacturing needs, why not pop down to PCBWay's website? Something tells me you won't regret it. Commodore helpfully didn't put an on-off switch on the back of the computer, so I've got the power supply here on the desk in the corner, so I can reach the switch easily. So we'll power it on anyway and see what we get. It took me quite a while. As you can see, we get a green screen. It took me quite a while to find the actual RGB video cable for this thing. I've had it for a few weeks now, this machine, along with the ST, while I deal with the Q. I'm finally getting on top of the Q, but anyway, the picture looks pretty nice, such as it is. At least it's sharp, or the edges are sharp, and we get a kind of a flashing green screen. I had a quick look because I can't really remember offhand what the diagnostics were. But yeah, the Amiga, certainly the 600 anyway, it helpfully has a series of flash codes or visual indications of what the problem might be. And this particular flashing green screen indicates a problem with the RAM. So there we are. So we'll turn it off, we'll take the board back out of the case again, and we'll see what we see. Now you've got to be careful when you take the lid off here, because of course we've got the keyboard flex connector to disconnect, and it's a little bit fiddly. There we go. And I forgot to plug the front panel LEDs in when I put the case back on, so that's why we didn't get a power light or anything. That would have been a bit of a red flag normally, but so here we are anyway. So this is the board. We'll take the floppy drive out because we don't care about that at the moment, so we'll get rid of this as well. Oh Christ, yeah, that's stiff. Misses?
Sounds a bit rude. Thank you for giving me the clap.
So here's our Amiga 600 motherboard. Now I've had a quick look at a couple of things online, the board overview, to get a general idea of what's what. I'm used to the A500 layout. It's a hell of a long time since I've seen one of these things. So we got the RF modulator, that's the power jack, that's the video jack. I think we've got a parallel port, probably an external hard disk interface of some sort, probably a serial port, floppy header, that's the keyboard header. What's this crystal here? 28 megahertz, and that one's 4. I can't remember that. Does this run at about 8 megahertz? This thing. Anyway, where's the CPU? 68,000, where is it, there it is. So there's the CPU soldered to the board. Well, we know that works because pretty much works because we get a picture. That it will be the kickstart ROM. There's a lot less in this machine than there was on the A500. They've obviously amalgamated a lot of glue logic and such into a few programmable chips. But the RAM, we've got two SRAM chips here. I think they're 512k each. I'm assuming this thing has a megabyte of RAM. So so that's probably what we're looking at. But the thing was, that's not what struck me when I looked in here for the first time. We'll go in a little bit closer and I'll show you what I did notice immediately. So I don't know how well it's showing up on the screen. I've got this LED magnifier thing now. I'll turn that light on, it might improve the situation a bit. I'm actually running a new sort of light and camera setup here. I've completely revamped everything, and getting light on the subject is still proving a little bit problematic, but anyway, I've put this ring light on so we can hopefully have a better look of what's what. So the first thing I noticed here, if we look at some of these capacitors, as I say, it's very, very difficult to see on camera, but some of these have leaked anyway, and when you have a really close look at some of the legs on these chips, there's all sorts of gunk and corrosion all over the place. Now, I don't know, it's near the RAM, so I haven't actually checked out whether or not this section of the board is concerned with RAM. I mean, it's also near the floppy connector, so this could be responsible for the floppy disk. But the first thing I noticed here, I thought these have leaked. These all look in a pretty sorry state. So somebody online, anyway, when it comes to RAM problems, he whipped off one of the RAM chips and he got lucky straight away, and the machine powered up, obviously with half the memory capacity. But so what I'm proposing to do first, however, just on the off chance that cleaning the board up might solve our problem, because it needs doing anyway, is I've bought this recap kit. Rather than hunting around for individual caps, I thought I'd just buy one off eBay, and I'm sure it's very good. It wasn't even £10. So there you go, it came from Retrofix. And so we're just going to recap the whole board first and clean it up and flood it with Amtech flux and whatnot. And hopefully we'll see a difference, but I'm not really holding my breath. I'm not imagining that recapping the board is necessarily going to fix the computer, but it might, and it needs doing anyway. So that's what we're going to do. So I'm going to take the board out of the case. There's only a couple of screws holding it in now, I think. And I hate this shielding, I just think I'm going to cut myself on it. So I think we want the shield off the back of the board as well. So for that I'm just going to use the, just going to undo these little nuts. The shield's pretty nasty, it's quite badly rusted. So once this is working, I don't know what the owner wants to do with it in terms of aesthetics. He seems like he knows what he's doing anyway, he just didn't want to get his hands dirty with this particular pair of machines, whether through lack of time or what have you, but I'm sure any other housekeeping tasks he'll be keen to do them himself when he gets it back. Alright, so that should allow us to get the shield separated from the motherboard. There's a couple of screws on the joystick ports as well, I forgot about. There we go, now it comes out without it. There we go. Now we've got the board out, we will turn on the equipment, hot air and soldering iron, and we'll try and get into cleaning up this area of the board. I'll try and film this as best I can. It's going to be difficult, there's just no getting around it. So yeah, for example on this LF347M chip here, U15, we've got all the nasty gunk on the legs, particularly the front here where that capacitor has leaked all over them. So I'm just going to put a little bit of flux on there, and I'm going to renew the solder on the front of that chip just to make sure we don't have any shorts, and it should clean up quite nicely. There we go, and we've got the stink of leaked capacitor contents radiating all over the place. Likewise on here, corrosion. So everything that was in a line of sight from these. There's a 555 timer there, that's interesting. That's got caught with the corrosion as well. I mean, you could get a toothbrush and IPA on this, but I'll do that anyway after I've done this. I don't think it's gone any further than that, so let's just clean all that up. We'll give that a proper clean later on. Just for now, I just want to get the thick off, as it were. So it looks a bit less terrible. I'm going to turn it on just for a laugh, just to see what we get. We won't get anything different, of course, but well, hopefully it hasn't gotten any worse. Right, so let's see what we get now. And we get exactly the same thing, of course. So, although I'm going to recap this board anyway, I'm thinking actually a quick way to try and eliminate the RAM is to just take one of them off. And I've actually missed a little bit of corrosion on the front of one of those RAM chips over here, so I'm just going to quickly give that a little dab of flux. Is anything around the back? The back doesn't look too... Oh, there's a bit around the other side as well. But as I expected, that hasn't really changed anything, so what we're going to do now is we're going to take one of the RAM chips off the board. So we've got one DRAM off the board. Let's see if this changes things in any way, shape or form. And it doesn't. So, did we take the wrong one off, or are they both bad? Alright, so here we are a week or so later probably. I've bought a couple of 4 megabit NAC DRAMs to replace the RAM that's assumed bad on the motherboard. So at this point I'm fitting it. I did switch the original DRAMs round. I've taken the top one off, or the bottom as you're looking at it from this perspective, and swapped them over, but it didn't do any good. So I was assuming they were both bad, so we're just going to replace them. So I've slathered the second DRAM in flux here, and I'm using the hot air rework station to remove it from the board. So it's just getting ready to go there, and I've managed to get it off the board without dragging any caps off the board, because obviously everything in the immediate vicinity, the solder goes and melts on that as well. So it's very, very easy to drop the chip and knock some capacitors or other surface mount components off the board when you're doing this. So having taken the DRAM off the board, I'm adding Amtech flux to the pads, and I'll probably be letting the board cool off just a little bit before I start using braid to wick the old solder off the pads, and then I'll clean it, of course. So there we go, I'm wicking the pads now. I'm going sideways. Now, experience has shown me this is normally a bad idea if there's a lot of heat still in the board. That's why I've let it cool off a little bit. It's very easy to drag pads and traces off the board. Usually it's best to go in a direction parallel to the traces, but in any case I'll let this cool. I've had enough nasty experiences in the past where I've hot aired a chip off the board and then gone straight in with the braid and just wiped some stuff clean off the board, and it's been a complete living nightmare. So I don't do that anymore, but in any case you get a feel for these things eventually, and of course it's very, very convenient to do what I'm doing there and just sliding the braid across the board with the soldering iron on it. You do not want the braid to stick. So if you take the heat off that braid at any point, it's going to stick to the pad, and that's when you're liable to pull something off the board. So as long as the heat is constantly applied and I'm moving pretty quickly across those pads, I'm just wiping away all that old solder, and no problems whatsoever. Now I'm coming in with a bit of kitchen towel and some IPA just to wipe all that flux away and leave some nice shiny pads ready to be tinned and fluxed up in preparation for the new DRAMs. So there's our new DRAMs, and I'm now going to put a little bit of flux on those pads, get them tinned up, and then we will hot air the chips in place. So here we go with the flux, and just a little thin stripe of flux over all those pads, obviously on both sides. And now I'm going to tin them because obviously we need some solder there, so that when I apply hot air from the top, that's going to melt and it's going to attach the chip to the board. Now it's getting these things positioned correctly, which tends to be the tricky part, but at least we've got a proper footprint on the silk screen, and as long as it's roughly in the correct position, it's going to slide into place of its own accord once the solder melts. But obviously you need it in roughly the correct place, and of course the problem being with the pads being tinned, they've got little domes of solder on the top of them, so when you try to position the chip over the top of the tinned pad, it's prone to sliding off sideways, so that's something to watch out for. But that one looks like it's gone on bang on target, so I'm just going around the edges just to make sure everything melted, and that looks to be nice and straight. So that's it, it's on, so we'll just let that cool off a little bit and then we'll do the other one. But no, in fact it looks like I wasn't entirely happy with the positioning of that one, so I'm going in again and I'm just going to nudge it into place so that it's a bit straighter. Perfectionism, you see, that's what it is, perfectionism. And same thing with the second one, just making sure everything's nice and melted on the second chip. I think I got that one bang on target first time around, so I didn't have to faff about straightening it afterwards. So we'll just let that cool off, and that is the RAM replaced. Obviously we'll get a little bit of a clean up afterwards, but that's it. RAM replaced on the A600. And there we are after cleaning up. Doesn't it look lovely? You wouldn't think anybody'd been messing on with it. It just looks like it just came out of the factory. So question is it going to work? Right, so we've got the RAM on the board. Let's plug things in and see if we get any signs of life. Power jack wasn't in properly. Oh, we've got a different colour now. It was green before, but now it's blue. I don't know if that's a different error code. Oh, right, it boots. Brilliant. So the owner was actually correct, and the diagnostic colour of green was correct. It was the RAM, so replacing the DRAM on the board has actually resulted in a booting machine, which is good. But there's something not quite right here with the colour. It looks like it's got a greeny blue tinge to it. I'm wondering, because when the machine boots up successfully, isn't the screen normally white rather than turquoise? So I don't know if I've got a problem with the video cable or something here, because it is a bit of an old cable. So I wonder if the red channel is broken. I'll have a look at the cable and see what's what. Right, so I've had the cable apart, and I've measured continuity on the red RGB line right from the jack to the monitor. That's fine, there's no problem with that. So the problem appears to be something on the board, unfortunately. Now I've had a closer look at this area here. If we get in, actually getting a little bit closer. So if we look at this area on the board here, this is where the video output is. And the other thing I noticed as well on the board, incidentally, I tried the composite video as well, and there's nothing at all on the composite video. It's absolutely dead. So while the machine boots up now, we've still got a problem with video. Now I'm going to recap the whole thing. So we've got the recapping kit here, and it helpfully tells you which value actually goes. So we're going to do that as a matter of course. But I don't know if that in itself is going to fix things. Now if we look at this area here, this chip here, CX, we can't even read it, I'll have to get the magnifier onto it. There we are. Right, so it's CXE1145M. Right, I've got myself a schematic here, E600 schematic. And if we go, here we are. So if we go down to this page here, this is the video circuit, and there is CXE1145. So that's the encoder responsible for, among other things, it looks like it does composite video and RF and RGB. So if we look here, these are the red, that's red, green and blue. So what we've got here, we basically appear to be missing red entirely. And that's on pin 23, and it goes through a 1K resistor. We've got a 33K pull down resistor. We've got a transistor 2N3904, and then we've got another 150 ohm pull down resistor, and then a 75 ohm termination resistor. So we've got a problem. Either there's a problem with this chip, or there's a problem with some passive component on the way out. For example, a transistor could be bad. But if we look at the board, we can see that these caps that we're going to replace anyway have all, well, some of them have leaked. And it's difficult to pick up on camera, but yeah, if we angle the board a little bit like that, you can see this is all very grimy. And the legs of this encoder chip look absolutely terrible. That was actually bridging pins 1 and 13 on that chip. I'm assuming that's for decoupling. It's fallen off while I was poking around with this chip, so I'll put it back later on. But I've tried it without that cap in place. It doesn't make any difference. We've still got the same problem. But yeah, this whole area of the board is in really poor shape. So if we do a couple of tests anyway, a few sanity checks before we start looking at it with the scope. I'm hoping that what happens is that I just replace the caps and that somehow fixes the issue, but right, let's have a look. So pin 23 of the encoder is the red out signal, and it goes from there to R231A, which is up there, and then from there it goes to there, which is the transistor, and then it comes out the transistor, goes back through the board, and then on its way to the video jack. So we've got a problem somewhere along the way. I think we'll have to get the oscilloscope and probe the red pin to see if we're actually getting anything. Well, it's like an operating theatre in here, so right, let's we're going to need power on, oh dear me, I'm running out of power jacks here. Right, so let's connect one of the probes to ground, if we can find a spot with ground on it somewhere. Right, so pins 21, 22 and 23 are red, green and blue. So let's say on the green pin, which is pin 22, when we turn the machine on, since the initial screen is white, we should see some activity. And then when that goes to the next screen, it should change. Now if we probe the red pin and we turn it on, we appear to get activity there as well. So we are getting a red signal. I think what we'll do is we'll probe the other side of the transistor. We'll try the blue one, which is Q232. So yeah, we've got activity on the blue one. What about this one? Yep. We should have red. We've definitely got some activity on red. We've also got composite video out, which is on pin 20. It's got 24, 23, 22, 21. So there's our composite video out. So it looks like the chip works. What I think I'll do here is I'll clear this area, clean it up, replace these caps, tidy up this chip. And if we still don't get composite video in red, then I think we'll start to suspect maybe something on the other side of the board, even though things look okay. So since I was kind of out of ideas for the time being regarding the fault on the red line of the RGB out, I decided to press on with the recapping job because it needed done anyway. And I started in the vicinity of the video circuit because that's where we had a lot of leakage, and that's where we still had problems. So I figured that made sense while I had a bit of a ponder about the video issue. So that cap's just about ready to go. I've already taken a couple of them off, as you can see. I think getting those caps off the board without destroying the connector next to them is going to be very, very tricky. So I might have to use the iron, or I don't know. I might leave them for the moment. That looks extremely difficult. So now we can have a closer look at this area of the board where I've just removed all these caps. It doesn't look very nice. I think we'll... I don't really want to take this chip off, particularly at the moment, because the legs are quite badly oxidized, but we've got solder balls all over the place. So we'll just clean this up, fit the new caps, try and make it look as nice as we possibly can, and look for any breaks anywhere, and see if this makes any difference. Alright, so I've given this area of the board a really good cleaning. I had to scrape the sides of these resistors here, same with the transistors. They were all so covered in corrosion that even with loads of flux, the solder just wouldn't take. So I just scraped away the corrosion at the sides of these resistors. The pads are okay. This chip, it's on. It's what I'm going to do now is I've just cleaned this with alcohol to get rid of some of the flux, and then I'm just going to take it downstairs and I'm just going to clean it in the sink with a toothbrush, just to get rid of some of this excess flux that's dried onto the board here. And as far as I can see, everything looks nice and silver now anyway, so we know we've got good connections on everything we can see here at least. So I'll clean it, come back, we'll put all the caps back on, and I guess we'll see if anything changed, and I have a feeling it won't, and we're probably looking at something. Well, in fact, what I'll do after I've put the caps back on is we'll actually continue to trace the red signal through the board, through to the other side of the board, and we'll see what's actually on the jack, which would probably been a good thing to do in the first place anyway. But we'll get the caps back on the board first. Alright, so here's the board after being cleaned in the sink with fairy liquid and boiling hot water. Just this area of the board here, and my god, what a difference. What a difference. That looks really quite nice, I think. So that is all ready for our new capacitors. I'm quite pleased with how that's turned out. But you can see how the leaky cap, obviously this cap must have leaked, and it's actually damaged the solder mask there. But other than that, it's not actually too bad. I mean, this encoder chip, now it's been cleaned up, looks absolutely fantastic. You can see all the pin ones a little bit crusty there, but we can see that having reworked all the legs of the chip with flux and solder. So I've got a high level of confidence that all the vias are good, and that even if this in itself hasn't fixed the video issue, know that we're working with sound connections. Alright, so we've got the majority of the caps on the board now, and I think it looks very nice indeed, this area, this video circuit area. I managed not to melt the connector here, although I did realise actually after a couple of goes of putting these things on that it was actually much easier to use the iron. I did, the first couple I used the hot air, it seemed to make sense, tinned the pads, low airflow, but no, it was just a nightmare, and this connector was starting to look worried. It's perfect as long as you tin the pad and put some flux on the board. You can just catch the outside edge of the pad with the iron, and the thing sits on. It sits quite nicely on there. So I've done those, I've done the other side of the board. I haven't done those two yet because I'm still planning how to actually get them off the board, probably using the iron and just reach behind this connector, but I mean they look fine. I'm not overly concerned about those ones. Anyway, so I think we'd better plug it in and test it, and if nothing's changed we're going to have a bit more work to do. I'm fully expecting that to be the case, of course, but this, the tidying up of the board and the recapping, it needed to be done, so it's done. Hopefully it hasn't caused any problems in itself. So here we go. Switch it on, see if we get anything. Still turquoise. God! So this is extremely puzzling because before I did this recap job, I've actually traced the red pin from the connector to the right back to the chip here, and we've seen on the scope that it's actually putting out red. So where's the red? This is very, very strange. I might have to, for a sanity check, go and get an A500 from next door, plug that in, and just to verify that there's nothing janky going on with this damn cable. But I mean, why would it be the cable? Because, as I said before, Composite doesn't work. But well, at least the machine still boots, I suppose. We haven't ruined it by recapping it. Right, well, I've actually found the fault, and I could have saved myself a lot of time by probing the correct pin on the transistor for the red signal. But in my defence, tracing that signal back from the video jack to the encoder here was not particularly easy. It was easy to get fooled by the vias, trying to pinpoint the vias coming through the board from one side to another. Anyway, the situation is that I used the scope to measure the output on pin 23 of the encoder, which is the red output, and I traced it through the resistor here and the transistor, but of course I measured the wrong pin of the transistor, and I thought I was getting a high red signal coming off the transistor when in fact I wasn't. In any case, this became apparent eventually when I was tracing the circuit from the jack to the back to the encoder. I realised the mistake, and of course I should have been measuring, well, the transistor is gone now, but I'll explain why in a minute. I should have been measuring this pin here at the top left, and I was measuring the bottom one, so more fool me. In any case, when I eventually measured the correct pin, which is this one at the top left, it was flat. There was no activity whatsoever. So we have red comes from pin 23, it goes to the top of that resistor, and then it goes from the bottom of that resistor to where? There, the top right pin of the transistor. Now 5 volts is connected to that bottom pin, that's what threw me. What I should have been measuring is this pin at the top left here, and when I probed that with the scope, there was nothing going on. So immediately I concluded that the resistor was broken, but to verify that, what I've actually done off camera is I've taken, I think this is the green transistor, taken the red transistor off, there it is, line there, and I've moved the green transistor up to the red spot. So I think what we should have now is no green, but we should get red, hopefully, if the prognosis is correct. So let's have a look. So if we power up now, get the camera out of the way, there we go, we've got a purple screen this time, which is red and blue, no green, so there we are, and now we've got red. So that's it. So that was the problem all along, was a bad transistor. Right, now the thing is to find a transistor. Right, I found a 50 volt NPN transistor. I was looking for one identical to that one, but I can always change it later on. I took this off an old TV motherboard actually, but they're always a good source of parts like these, and I scrutinised the board and I found something and looked it up, and it looked about right. The other one's 40 volt I think. This one's 50 volt rated. And I've put that where I stole the green one from, of course, so let's test that. And we've got a white screen, great. Excellent. Ah, brilliant, we've got the proper colours. Yes, superb. So we've got all the colours now. Now the next thing I want to know is, does a composite video suddenly work, or have we in fact got a second bad transistor on the board? So we'll turn it off again and see if we've got composite yet. I can't see why composite would suddenly start to work, but we'll see. Right, let's select the source on the TV. I'm determined to get everything working on here, I really am. Switch on. Do we get anything? Nothing. So Composite doesn't work yet. I wonder if it's the same problem again somewhere. So we'll have a look at the schematic and we'll see what exactly happens with Composite Video then. Right, so here is Composite Video out in pin 20 that we've just measured, and it was a flat line. It goes through that capacitor which I have just changed. Then it goes to a 75 ohm resistor here. I wonder if that encoder has got a problem. So it can't be the cap because we've just replaced it. Can't be the resistor. Hello, and here we are again, about 3 weeks later since I filmed the last scene of this video. Much has happened in the intervening time. I've done some off-camera work here which I've just about completed. I want to go into a bit of background about what the actual problem was and what the solution will hopefully turn out to be. So we reached the stage where RGB video worked okay. That was a bad transistor on the red RGB line. Obviously we've got the RAM replaced, we've cleaned up the board, there was some corrosion, but I came to a bit of an impasse because I couldn't get Composite Video to work. Now I doubt the owner actually wants to use Composite Video, but I did consult with him anyway when I suggested a solution, which I'll go into in a minute, and he agreed to it. I think he'd be happy if the thing works completely rather than worked partially. Definitely nice to have all the video outputs working. So let me tell you what the problem actually is. So if we look at this area of the board here, I'll just get my little pointing device. So if we look at this section of the board here, I did a bit of reading into how this works. Now here's our encoder chip, which I think I've already talked about. But this is the replacement encoder chip. I'll go into that in a second. Now the encoder chip, as well as providing the RGB signal, the RGB video signal, it also produces the composite video signal. It's a Sony part. The composite signal relies on a band pass filter and a delay line. Now the delay line comprises 3 inductors down here, the little silver cans, and there's also a band pass filter up here. Now I found online some articles about this precise issue of having no composite video or having poor composite video, and I managed to find a forum post where somebody described a way of testing these things in situ to figure out, before you actually take them off, if one or more of the delay line inductors has actually got a break or a fault on it. And I did this test anyway with the multimeter, and sure enough it turned out that one of the inductors was broken. The guy then went on to explain how you can actually take them apart, so I had to go at that. I took the whole thing off the board. You have to prise the can open, and of course in my case, when I prised the can open of the actual inductor that looked like it had a break in it, the damn thing fell apart anyway. So and he suggested that you can fix it with tiny little lengths of wire, and at that point I just thought this is too fiddly, it's too small, and I'd already noticed that there were a few alternative solutions to this problem of the composite video output. So this is one of the articles about this precise issue. Amiga 600 video encoder upgrade. That's the delay line that I was talking about, which is now off the board, and there's the original encoder chip, and this one had the cap across diagonally like that, exactly the same. So that's what I've taken off the board. I should probably take off the band pass filter as well. So anyway, the CXA 1145 design relies on 2 specifically delicate external components, 1 delay line and 1 band pass filter. Those were my primary suspects. In the Amiga 600 design they are called Z221 and Z222. The data sheet is pretty vague regarding these components. It mentions that the BPF should also be centered around 4.43 MHz for PAL and 3.58 MHz for NTSC, The color carrier frequencies and the delay line should be 180 nanoseconds in both cases. So he goes on to describe how he tried to clean up this part of the board, and he reckons that the cans are sensitive to cleaning detergents, and he reckons that's what messed them up. He's got a diagram here. So this got him thinking about a possible replacement for the Amiga 600 1200 analog video section. Now this particular person has gone with a CXA 1645, which is almost pin compatible with the CXA 1145, and it does not depend on an external bandpass filter and delay line. So he goes on to describe this modification. Now this particular one requires, as you can see from this picture here, quite a lot of stuff bodged on top of it. Obviously I did have a look online to see if I could source one of these. I entertained this as a possible solution. Any solution that did not rely on those cans on the board, the delay line and the bandpass filter, I was interested in it, depending on how much the part would cost, of course. So he describes how to do that fix. I can't remember whether it's in the comments on one of these pages or on a forum somewhere, where somebody, as I say, suggested that you could actually fix the delay line chip, but I wasn't going to do that. Now there's another one. As I was trying to balance availability and cost with complexity and effectiveness, I found this one here, which talks about the CXA2075M, and this person had the same. This is by High Puff. This person encountered exactly the same kinds of issues, problems with the delay line, bandpass filter, etc. So this particular solution uses a different chip, and this one I managed to find on eBay, but it was in China. So I ordered one of these from eBay, and he describes anyway what to do after you actually get the thing. You remove a few passive components on the bottom of the board under the video circuit. You remove pins 8 and 9 from the chip. They are the ones that were originally connected to the delay line and the bandpass filter circuit, and you stick the chip on the board. You short out the two traces that went to those removed pins. You put a resistor across the chip like so, and this enables the internal analog video generation circuit, and hey presto, he appears to have composite video. Not only that, but this chip actually produces S-video as well. I'm not going to do it in this video, but you could actually tap S-video off this chip, and you could put an S-video connector on the back of the Amiga and you'd have S-video as well. As I say, I'm not going to try that, because all I wanted to do was get working composite video. So that's the background anyway. So let's go back to the motherboard, and of course I can step through what was actually done here. So as per the pictures you've just seen, there's the chip on the board. So I took the original encoder chip off, I took off those additional passive components on the back of the board. Of course I have no idea whether this is going to work. I don't yet know if we got a bad chip. I mean, it took, from the point of ordering the chip, it took about 2.5 weeks for it to get here, and I only ordered one because they weren't that cheap. So anyway, the chip's on, the two legs are removed. I've shorted out the those two pads there as per the instructions, and I couldn't even find a 2.61 ohm, 2.6 kilo ohm rather resistor. I couldn't find one in the parts box, so I've just stuck a 2.2k resistor over the chip like that. So whether that's going to work or not, I just don't know. But if it doesn't, I mean, I'll assume it's because the resistor isn't the correct value, and maybe replacing that will fix it. So all may not be lost. I mean, if this doesn't give us composite video, I think I'm just going to give up at this point if the owner's agreeable to that, because I can't go back to the original analog circuit because I've replaced the chip now, and I only hope that RGB still works as well. Otherwise, we've actually made the situation worse. So I think the best thing we can do is just plug it in and test it and hope for the best. Okay, so I've got my ridiculously oversized RCA cable here. Let's grab the power cable. Get the power supply on the desk. Right, there we go. It's the most inconvenient way of switching a computer on this thing. Right, so we should be rigged up for composite video here, so let's turn it on. As I say, probably there seemed to be talk that the resistor value is pretty critical, so I'm not really expecting this to work. So we'll just see what happens. White screen. Well, we've got a signal. We've got a composite signal. Is it going to boot? Yes! That's it. Brilliant. We've got a composite video and the machine boots. Marvellous. I mean, it doesn't look fantastic, but that's kind of composite video for you. I can't believe it. So the resistor value mustn't be as critical as I thought. I mean, I don't think it actually matters what it looks like. I just want it to work. I'm more than surprised, actually. This little chip's winged its way all the way from China, found its way on this board, and now we've got composite video. I think I better check that RGB works as well, though. Right, so if we just switch sources, we should hopefully get RGB, hopefully. Come on. Yes! RGB still works. Excellent. And it's super crystal clear, of course, RGB. That's brilliant. It's finally done. I've had this board here for about 6 weeks. Right, so I can personally vouch for this CXA 2075M encoder solution. It's nice and easy. It just takes one resistor across the chip, take a couple of passives off the board, and it is done. So if you've got this problem and you can find one of those encoders, get it, because it works. So to recap what we actually did to this computer, the owner's suspicion that we had a RAM issue was absolutely correct. As I've said, the owner he's fairly technical minded, so he knew what he was talking about, and he said it was probably the RAM, which it was. But of course, since the system was displaying a green screen when it was turned on, what we didn't know is that the red didn't work on the RGB video, so that turned out to be a bad transistor down here. So we replaced that, and I've actually replaced it with a proper part as well. I bought a strip of transistors to do the job properly. There's the original encoder chip, which has nothing wrong with it, so I'll keep that as a spare in case we have another machine in with a bad encoder chip, and I can just replace that chip, assuming the bandpass filter and the delay line are still working, of course. So that's handy. So anyway, there was corrosion on the board as well, so we've cleaned up the board, replaced the RAM, replaced the transistor. Then we didn't have composite video. I've recapped the whole board as well. Let's not forget we've done that. And so it's been recapped, cleaned up, new RAM, fixed RGB video, and fixed composite video with a new encoder chip. Like I say, I don't know how much he paid for this board. Apparently these A600s, I can vouch for that as well, having had a quick look on eBay. These are starting to appreciate in value, and I know the 1200s are especially desirable as well. So like I said, I don't know what he paid for this, but it's been quite labour intensive and parts intensive, this one. But the main thing is it's done, so hopefully he'll be happy with that. The same customer, he's left an ST here, an Atari ST, so I'm going to go and have a look at that one before, and hopefully that'll be a fairly straightforward fix. I'll probably make a video about it. And then you can come and pick your stuff up and take it away in the car. So that's it. So I hope you enjoyed this. It's a bit of a departure again. I'm very, very pleased that it came to a positive conclusion. It's a fix. Everything seems to work. I wish I had more means of testing things like the audio and stuff. But the thing is, the owner is pretty technically minded. I'm sure if there's anything else that he runs into, another problem that he runs into with the board, I'll be delighted to help. But it might be something he can handle himself. It's not like he's completely clueless. Far from it. So, oh, you little bastard! Sonny! Little shithead! So I hope you enjoyed this one. It's been something a little bit different. It was certainly welcome from my point of view to work on something a little bit different. It was pretty challenging. I've certainly learned a lot about the Amiga. So I want to thank everybody who watches the videos, who interacts with them, likes them, shares them. I'd love to hear your comments below if you've maybe run into a similar problem and solved it in a different way, etc, etc. Of course, a big thank you to the video sponsor, and a big thank you to my generous patrons who really do keep this channel running. So with that, it's been quite a long one, quite an in-depth one, so I'll bring it to a close without any further ado. So thank you very much again, and I will see you in the next video, so bye-bye for now.